Hello dear students, good evening to each and everyone. All of you welcome on Wallah English channel. We are studying signals and system in comprehensive manner. Already we completed total 21 lectures in this course and this is lecture number 22. From today we are going to study classification of signal. This is part 1. First of all tell me, am I audible properly? Audio and video both are clear to you people? Tell me in the comment box. I hope audio and video. Yes, good evening to each and everyone. So today's class also very much important guys. Okay. Shall we start now? Okay. So let us start guys. Classification of signals. Classification of signals. So part 1. So in today's class, we will study right sided and left sided signal, causal and non-causal signal, energy and power signal. If time permits, then I will start odd and even signals also. Okay. So classification of signals. Classification first is right sided and left sided signal, then causal, non-causal and anti-causal signals, then energy and power signals, then odd and even signals, periodic and aperiodic signals, bounded, unbounded signals, analog and digital signals. One more classification we will see, that is random and deterministic signal. Important part, important classification, time consuming, which we will solve more number of questions, that is odd and even signals and periodic and aperiodic signals. Odd and even signals will take I think 2 to 3 lectures. Periodic signals I think it will take 2 lectures. So 3 hours here, 2 hours here, and remaining all are like 30 minutes. So this complete topic is of like 7 to 8 hours, but it's very much important guys. Okay. So let us start with very first classification, that is right sided and left sided signal. So what is a right sided signal? A signal which is defined for t greater than or equal to t naught. Okay, it is going towards right side from the starting point. The signal is going towards right side from the starting point. It is known as the right sided signal. Okay, so a signal which is defined for t greater than or equal to t naught is said to be right sided signal. Here this t naught can be 0, it can be positive, it can be negative also. Say for example, number 1, x of t is equal to q of t minus 1. Q of t minus 1 means t here. It is starting from what? It is starting from t equal to 1 going towards right side. It is 0, 1, amplitude is 1. Okay. Q of t minus 1. Next, number 2, suppose second example, x of t is equal to q of t plus 2. Q of t plus 2. Starting from t equal to minus 2. t equal to -2 and going towards right side. T equal to -2 going towards right side, amplitude -2 going towards right side. This is known as what? Right sided signal. Okay. And number three example, let us consider x of t equal to q of t. Okay. This starting from 0 and going towards right side. So this is also the right sided signal. So all three examples are of right sided signal. It is going right side from the starting point. This is also right sided signal, this is also right sided signal, and this is also right sided signal. And exactly opposite is what? Left sided signal. Left sided signal means a signal which is defined for t less than or equal to t naught is said to be left sided. Here t naught can be 0, it can be positive, it can be negative also. Say for example x of t is equal to q of minus t. Simply you can say if it is minus t, variable is minus t, then it is left sided. Starting point is whatever it is, okay, -2. Okay, so here -0, -2, and this is amplitude is 1. It is going towards left side starting from the t equal to -2, so this is left sided signal. The first example, let us take second example. X of t is equal to q of minus t plus 1. So going towards left side starting from t is equal to -1, 0, amplitude is 1 guys, amplitude is 1. Clear to each and everyone? Number 3, suppose x of t is equal to q of minus t. Okay, so this is also example of left sided is 0, here 1. So again you can see here starting from +2 here, b plus, sorry, here this is, okay guys, my mistake here. Starting from -2 and going towards left side. Amplitude 1. See, this is starting from -2 going towards left sided signal, starting from +1 here. It should be +1. Starting from +1. Okay. Starting from +1 and going towards left side, so left sided signal. This is also left sided signal. Okay. These are the infinite duration left sided, right sided signal. It can be finite duration right sided, finite duration left sided, finite duration both sided also guys. That also we will see. Clear? Clear to each and everyone? Tell me in comment box. I hope all the students are getting. So this is what? Right sided and left sided signal, first classification. Next we will see causal, non-causal and anti-causal signals. This is very much important. For every causal signal, x of t is 0 for t less than 0. Amplitude is 0 for negative value of time t. If x of t is 0 for t less than 0, that is known as causal signal. And for every anti-causal signal, x of t is 0 for t greater than 0. X of t is 0 for positive value of time t, that is anti-causal signal. And the signal which is not satisfying above two conditions is known as what? Is known as non-causal signal. A signal which is not satisfying above two conditions is said to be non-causal signal. Let me take some example. say for example, let me take one example. Suppose x of t is equal to q of t minus 2. Q of t minus 2 starting from 2 and going towards right side. Amplitude is 1. Number 2, x of t is equal to q of minus t minus 1. So starting from minus 1 and going towards left side. Okay. For 3, say for example, of t q of t plus 1. This is 1. It is 1. Now tell me, first one is causal or non-causal signal or anti-causal? Causal, non-causal, anti-causal. Or I am expecting answer from each and everyone in the comment box. Causal, non-causal or anti-causal? I am expecting answer from each and everyone. First signal. Causal, non-causal, anti-causal. Here you can see x of t is 0 for t less than 0. First condition. Here x of t 0 for t less than 0. That's why this is what? Causal signal. Correct? What about second one? Here you can see x of t is 0 for t greater than 0. So it is known as anti-causal signal. Anti-causal signal. Correct? And here you can see, guys, x of t is non-zero for t less than 0 and it is non-zero for t less than 0. Clear? X of t is present for t greater than 0 also, it is present for t less than 0 also. So this signal is not satisfying above two conditions, any of two conditions, correct? So here this is known as what? Non-causal signal. Is this clear? Clear to each and everyone? Okay. So this is causal, this is anti-causal, this is non-causal. Now let me write some example. Just wait for a minute. So wait for a minute. classification of, yes, now all of you please concentrate here. See here guys, here certain examples are written and we have to identify the causal, non-causal. Okay. So first of all, sorry, you have to identify, yes, causal, non-causal and anti-causal signal. First guys, tell me, this is right sided, left sided, बताइए. This is what, sorry, tell me guys, this is right sided signal, correct, and this one second also right sided signal, then this one is also right sided signal, correct. This one guys is left sided signal, this one, this is also left sided signal, this one, this is also left sided signal. This is what finite duration right sided we can say. This is finite duration right sided. Here we can say finite duration right sided. This is finite duration left sided. What finite duration left sided, and this is what infinite duration both sided. Infinite duration both sided guys, correct. This is for everlasting signal guys. Infinite duration both sided signal. Finite duration both sided signal. Infinite duration. Okay. So first tell me guys, this one causal or non-causal. First one is, of course, this is causal. This one is causal or non-causal, anti-causal. So as you can see here, t greater than 0, x of t non-zero, t less than 0, x of t non-zero. So this is non-causal signal. This one, so for t less than 0, x of t is 0. So this is causal signal. This one, anti-causal, causal, non-causal. This is non-causal signal. What about this one? This is anti-causal signal. Anti-causal signal. What about this one? This is also anti-causal signal. Here, this one only defined for right side. That's why causal signal. This is anti-causal signal, and this is non-causal signal. Okay. Clear? Now important conclusion guys. Now important conclusion from this. Important conclusion. So from 1, 2 and 3, what we can conclude? From 1, 2 and 3 we can conclude guys, all the causal signals are right sided. Each and every causal signal is right sided, but vice versa may or may not be true. That means we cannot say each and every right sided signal is always causal. Each and every causal signal is always right sided, but each and every right sided signal not always causal. It may or may not be causal signal. This is the first conclusion. Similarly from 4th, 5th and 6th, what we can conclude? Each and every anti-causal signal is left sided. Each and every anti-causal signal is left sided, but each and every left sided signal is not always anti-causal. It may or may not be anti-causal, correct. Each and every anti-causal signal is left sided, but vice versa statement may or may not be true. So these are two important conclusions. Is clear? These are two important conclusions. What are that? So important conclusion, every causal signal is right sided signal, but vice versa may or may not be true. That means each and every right sided signal is not always causal. It may or may not be causal. Similarly, every anti-causal signal is left sided signal, but vice versa may or may not be true. You cannot say each and every left sided signal is always anti-causal. Clear to each and every student? Tell me in comment box. Is this clear, guys? Yes or no? Okay, very good. So this is all about what? Right sided signal, left sided signal, causal, anti-causal and non-causal signal. Now next classification is energy and power signals. Energy and power signals. Okay. So again, if the signal is energy signal, then its energy is always finite and energy signal has zero power, zero average power. And if the signal is power signal, then it has a finite power. Power is always finite. Then power is always finite, correct? And power signal has infinite energy. Okay. So energy signal requires zero power, average power, and power signal require infinite energy. Yeah. For every energy signal, its energy is always finite. That is, if x of t is if x of t is energy signal, if x of t is energy signal, then its energy is always finite. That is 0 less than energy of x of t less than finite, and its average power is correct. Average power is always 0, guys. Okay. And for every power signal, if x of t is a power signal, if x of t is power signal, then its power is always finite. 0 less than average power of x of t less than infinite, correct? And power signal require infinite energy. Energy of power signal already we have seen is what? Finite energy. So power signal has infinite energy and energy signal has zero power. This is very much important. Clear? Okay. Now again, all of you see here. Okay. See here. Now first signal, tell me, this is exponential decreasing function. This is exponential decreasing function. So tell me, it is energy signal, power signal. So how to identify whether the given signal is energy signal or not? If amplitude is decreasing, right side or left side or both side. If amplitude is decreasing, that means if amplitude is 0 as t tends to plus or minus infinite, if signal has 0 amplitude, then it is known as what? Energy signal. So this is the energy signal. Energy will be finite, guys. Energy signal, correct? Exponential decreasing energy signal, and energy signal has 0 power, average power is 0. Now this one, second, unit step function is u of t. So if maintaining constant amplitude for the infinite duration, and is a power signal, guys, correct? This is power signal, and power signal require infinite energy. Energy will be infinite. This is exponential increasing, guys. The increasing function. So each and every increasing function, whether it is increasing right side or increasing left side, correct, or increasing both side, infinite duration increasing function, then always it is what, neither energy nor power, because energy here infinite. See here energy also infinite and power also infinite, guys. So average power infinite, energy also infinite. So this is known as what, neither energy nor power signal. Clear? Neither energy nor power signal. Okay, neither energy nor power signal. Clear? Now this one, guys. Again, this is what, constant amplitude for the infinite duration. Constant amplitude for the infinite duration, guys. Okay. Constant amplitude for the infinite duration. So this is also what, power signal. Power signal, and power signal require finite energy. Okay. This is also increasing function. Number 5 is increasing function. See, number 5 is increasing function. If it is increasing function, then again this is what, neither energy nor power signal. Okay. Now here 6th number, guys. This is periodic function, sinusoidal periodic function, and I already told you each and every periodic function is a power signal. So this sinusoidal function is power signal. You will get the finite power a square by 2, already we have seen, and energy finite. Energy is infinite. Okay. Here now 7 number. Okay. Now 7 number. So it is what, exponentially decreasing, guys. Exponential decreasing. So as this is the exponential decreasing function, left sided, so of course it is energy function or energy signal. Energy signal has 0 average power. Now what about number 8, guys? Number 8. So here this is also periodic function, sawtooth waveform periodic function. And I told you each and every periodic function is a power function or power signal. This is power signal, and energy of power signal is always infinite. This is signum function, already we have seen signum function also power signal, correct. This is a power signal, and energy of the power signal is always finite, always infinite. Clear? Fine? Okay, very good, guys. Now again there are two conclusions, from this all 9 examples. Observation is what, each and every periodic signal is always power signal, but vice versa may or may not be true. Each and every periodic signal is power signal, but each and every power signal is not necessary it is periodic. Power signal may or may not be periodic, but periodic signals are always power. You can see here this is periodic, this is also periodic, or any periodic signal is always power, but power signal may or may not be periodic. You can see here this is the power signal, but it is aperiodic. This is the power signal, aperiodic. This is the power signal, aperiodic. So each and every periodic signal is power signal, but each and every power signal is not necessarily periodic, correct. Similarly, each and every energy signal is aperiodic. You can see here this is energy signal, always aperiodic. This is energy signal, always aperiodic. So each and every energy signal is always aperiodic, but each and every aperiodic signal may or may not be an energy signal. Each and every aperiodic signal may or may not be energy signal. See, this is the aperiodic, but it's a periodic. Sorry, this is the aperiodic, but it's a power signal. This is aperiodic, but neither energy nor power signal. This is aperiodic, this is also aperiodic. So there are important 2 conclusions from this 9 example. Conclusion number 1. Conclusion number 1, guys. Number 1 is what? Every periodic signal is always power signal, but vice versa may or may not be true. The first important conclusion. Vice versa may or may not be true means each and every power signal may or may not be periodic. correct? Similarly, each and every energy signal is always aperiodic. Each and every energy signal is always periodic, but vice versa may or may not be true. That means each and every aperiodic signal may or may not be energy signal. Clear? Fine. Now tell me, any doubt in this? Is this clear? There are again two important conclusions. So they can ask question like multiple select question and 4 options will be given, and you have to say out of 4 options how many options are correct or how many options are right or wrong. Fine. Clear to each and everyone? I hope all the students are getting what I am saying. Is this clear, guys? Fine. So we'll move towards the next classification. Okay, very good. Now the next classification. Next classification is, this is very much important, and in this we will solve more number of questions, and this is also a time consuming topic, and it's very much important. You will find so many questions from this topic. So next classification is odd and even signals. Odd and even signals. So first of all, let us consider x of t equal to a of t plus jbt. So this is the real part and this is the imaginary part. Okay, and this signal is known as what? Complex value signal. The real part. Okay, what? Real part, and this is the imaginary part. Real part is the imaginary part. That is known as what? Complex value signal. Okay. Next, if the imaginary part is 0, that means if x of t equal to a of t, if x of t is equal to simple a of t, that is known as the real value signal. And if x of t equal to jb of t, then it is known as what? Pure imaginary signal. Example of this. Example, x of t is equal to, suppose, complex sinusoidal signal e power jt is nothing but cos t plus j sin t. So this is known as the complex value signal. Real value signal, example of the real value signal is x of t is equal to simply exponentially increasing or decreasing function, the real value signal. And pure imaginary value signal, x of t is equal to suppose j t square. So this is what? Pure imaginary value signal. Okay. Now symmetry conditions are different for complex value signal and for real value and pure imaginary value signal. Okay. So first of all, we will study the symmetry condition for real and pure imaginary value signal. Real and pure imaginary, that means here I am writing symmetry condition for real value signal, x of t is equal to a of t and x of t equal to j e of t. Okay. So this is the pure real and pure imaginary value signal. Okay. So if pure real and pure imaginary signal is there, then for every even signal x of t equal to x of minus t, or if any signal satisfying this condition, if any signal satisfying x of t equal to x of minus t, this condition, that is known as even signal. X of minus t means what? Folding with respect to y axis. So first of all you have to do the folding with respect to y axis, and it overlaps the original signal, that is known as the even signal. Similarly, for every odd signal x of t is equal to minus x of minus t, that means what? First folding with respect to y axis, then folding with respect to x axis, and it overlaps the original signal, that is known as what? Odd signal. Okay. So, and a signal which is not satisfying above two conditions is known as neither even nor odd signal, nano signal, neither even nor odd signal. Okay. And this is the symmetry condition, again I am saying, for the pure real value and pure imaginary value signal. Okay. Now see here. Now guys, what we can say, each and every signal is sum of its a real part, it's a even part and imaginary odd part of the signal. What I am saying, each and every signal x of t is sum of its a even part and its odd part. Sum of its even part and odd part, this thing also we will see, don't worry. So what exactly we can say here, xe of t is nothing but xe of t is nothing but even part of x of t and x naught of t nothing but odd part of x of t. So any general signal x of t is sum of its even part and its odd part. Now so x of t equal to sum of its even part odd part. Now t become minus t, here t become minus t, x of minus t equal to x e of minus t plus x naught of minus t. Now see, this is the even signal, correct? Even part of x of t means even signal. So for even signal, can we write like this? X e of minus t equal to x e of t, because it's a even signal, and x naught of minus t, this is the odd signal. For odd signal we can write like this, yes or no? Here, from here guys, from this, x of minus t equal to what? Minus x of t. Okay, x of minus t is equal to x e of t minus x naught of correct of t. Okay, now let us consider this number 1. This is question number. If we add 1 and 2 guys, we add 1 and 2, 1 plus 2, 1 plus 2, then it gives the formula to calculate even part of the signal. We add two signal, this is x of t, this is x of minus t guys, and here it will be 2 times x e of t. You will get x of t plus x of minus t divided by 2. Okay, and 1 minus 2, it will give you the formula to calculate odd part of the given signal, x of t, odd part. Okay, so odd part x of t minus x of minus t whole divided by 2. Okay, so this is very much important formula. These are the formula to calculate odd part and even part of any signal, and this is for the continuous time. And same thing is applicable, same concept is applicable for the discrete time signal x of n also. So for the discrete time, what we can say, x of n is any discrete time signal, then for the discrete time signal, for every even discrete time signal, again x of n is equal to x of minus n. For every odd discrete time signal, x of n is equal to minus x of minus n. Okay, now again this formula also same for the discrete time signal. How to calculate the odd part or even part? Even part x e of n is given by x of n plus x of minus n whole divided by 2, and odd part is given by of n minus x of minus n whole divided by 2. Okay, the formula same as this one, guys, same as this one. X of minus n. Okay, these formulas you have to write in your short notes. Now we will solve some question based on this. Okay, even signal is also known as the symmetrical signal, symmetrical with respect to y-axis, and odd signal is also known as what? Anti-symmetrical signal. Symmetric means even signal, anti-symmetric means odd signal. Odd signal is anti-symmetric with respect to origin, we can, okay, or symmetrical with respect to origin. Okay, so let us solve some question, guys, based on this. Based on this, let us solve some question. So first, check symmetry of the given signals. Okay, they are asking to check symmetry of this signal. X of t equal to t square. First question. So if you want to check symmetry, then replace t with minus t. So left hand side t with minus t, right hand side also t with minus t. It is equal to square. Okay. So here nothing but what? Equal to x of t. Correct. So we got x of minus t, which is equal to x of minus t equal to x of t. That's why even signal x of t is said to be what? Even signal. Correct. Is the even signal. Yes or no? Second question. Here x of t equal to t cube. So x of plus t with minus t. T with minus t whole cube, minus t whole cube. Correct. It will be minus t equal to minus x of t. So we got here x of t is equal to minus x of minus t. That's why x of t is odd signal or anti-symmetric. Odd signal, or we can say another name is anti-symmetric. Clear to each and every student? Yes or no? Okay. Now next question. So here you have to check the symmetry of this signal. X of t is equal to 1 plus 2t plus 3t square. Just check the symmetry. And if it is nano, and then even nor odd, then you have to find its odd part and even part. If it is nano, then find its odd part and even part. So t become minus t. First replace t with minus t. So it will be like this, not equal to x of t. So this is not an even signal. Correct? X of minus t is not equal to x of t. So this is not an even signal. Now minus x of minus t, minus amplitude scaling, amplitude reversal, minus 1 plus 2t minus 3t. Here simply multiplying with minus 1. Again this is also not equal to x of t. Here conclusion is x of t is neither even nor even nor odd signal. Neither even nor odd signal. Okay. Then now we want to calculate its even part and odd part. How to calculate its even part, odd part? Even part is given by x of t plus x of minus t whole divided by 2. What is x of t? This one, 1 plus t plus 3t square plus x of minus t, this 1 minus 2t plus 3t square whole divided by 2. So its even part will be, the even part is, so 2t and minus 2t cancel out and it become 1 plus 3t square, the even part. Okay, the even part. Similarly, we can calculate its odd part also. Odd part is 1 by odd part. Odd part is given by x of t minus of minus t whole divided by 2. So x of t 1 plus t plus 3t square minus x of minus t 1 minus plus 3t square whole divided by 2. The odd part is odd part. What is the odd part? Here 1 and 3t cancel out, so it is 2t. This is the odd part and this is the even part. So here we can see, guys, x of t I am writing, x of t I am writing, see 1 plus t square plus, so this is nothing but what? Even part of x of t, and this is nothing but odd part of x of t. Okay, as I told you guys, each and every signal is sum of its even part and odd part of x of t, guys. Sum of its even part and odd part of x of t. Okay, sum of even part and odd part. Any doubt in this? Clear? I hope all the students are getting what I am saying. Fine, very good. Now next question number 4, e power minus t. So check whether e power minus t is odd signal, even signal, or nano. If it is nano, then find its even part and its odd part. t become minus t, will be e power t not equal to amplitude reversal minus e power minus e to the power t is also not equal to x of. Tell me whether this is odd or even. Here we can say x of t is neither even nor odd function. Now let us calculate its even part. Even part is given by x of t plus x of minus t divided by 2. So xc of t is equal to the power minus t plus the power t divided by 2. Now we know that according to the Euler's form, e power theta plus e power j, e power j theta, e power theta plus e power minus theta, it is nothing but what? Cos hyperbolic t, correct? Cos hyperbolic t. Similarly, if he wants to calculate the odd part is given by x of t x of t is e power minus t minus e power t divided by 2. So taking minus sign common, so it is e power t minus e power minus t whole divided by 2. So this term is nothing but what? Sin hyperbolic. It is sin hyperbolic t. So we know that, just I told you guys, every signal is sum of its odd part and its even part. So here e to the power minus t, which is equal to even part is cos hyperbolic t and the odd part is here minus sign minus sin hyperbolic. Okay, done. This is what e power minus t. This is the pure real value signal. This is what? Pure real value signal. I hope all the students are getting. Now important conclusion, guys. Important conclusion. Okay, first of all we check the symmetry of u of t. U of t signal, unit step function. Whether this is odd, even or nano. Of course, u of t is what we can say nano signal. Check once. X of minus t, u of minus t not equal to x. Of course, not a even function. Minus x of minus t, which is also not equal to x of t. Clear? First time reversal, then amplitude reversal, and both are not equal to x of t. So this unit step function x of t is nano, neither even nor odd signal. Okay. Now let us calculate its even part and its odd part. Even part given by is given by x of t plus x of minus t divided by 2. So x of t is u of t, x of minus t is u of minus t whole divided by 2. Now u of t plus u of minus t is 1, u of t plus u of minus t is 1. So it is nothing but 1 by 2 for all t. All t. Similarly, if we calculate its odd part, odd part is nothing but u of t, x of t minus x of minus t whole divided by is 1 by 2 signum of t, correct? U of t minus u of minus t is nothing but signum function. Signum function having amplitude 1 by 2. So the odd part and even part of u of t graphically. One part. Given part is given by amplitude is 1 by 2. Amplitude is 1 by 2 for all t. For t greater than 0 amplitude 1 by 2 and for t less than 0 amplitude 1 by 2. This is for the infinite duration. First, second, its odd part is the signum function. Signum function, guys. So here signum function having amplitude 1 by 2. Okay, here. So this is the odd part of this signum, odd part of the unit step function, and this is the even part of the unit step function. Any doubt in this? I hope each and everything is clear to people. Now next, important conclusion. If we add two odd signals, then the resultant signal will be odd, even or nano. If we add two signal, odd signal, t cube is odd signal and t power 5 also odd signal. So resultant signal x of t will be odd, even or nano. If we add two odd signal, then the resultant, then the summation will be odd or even. You can see here t become minus t, here also t become minus t. So of course odd plus odd, the new signal will be odd signal. Similarly, suppose I am adding two even signals. I am adding two even signal. Resultant signal will be even or odd. The resultant signal will be even or odd. So of course, see, t square is one even signal plus t power 4 is one even signal. Resultant signal you can check here, it's also even. So even plus even signal, I am not talking about the number, remember this thing. I am not talking about number, I am talking about signal. So even signal plus even signal, which is equal to resultant signal also even. Similarly, third number, if even plus odd, it can be plus, it can be minus also. Odd plus even or even plus odd, it will be odd even or nano. T cube plus t power 4 is equal to x of t. This is odd, this is even. So the resultant signal summation will be odd, even or nano. So you can see here it will be nano, guys. Check once, you will get nano, neither even nor odd. Here, neither even nor odd. Now next important conclusion. You multiply two odd signals, and the resultant will be odd, even or nano. Multiplication. Odd multiplied by odd. So it will be t power 8 and t power 8 is an even signal. So odd multiplied by odd, it is nothing but even signal. Number 5. Even multiplied by even. Even signal multiply with even signal, the resultant signal will be even signal multiply with even signal. Of course, t power 6 the even. The resultant signal is even. Now odd multiply with even, guys. Odd signal multiply with even. So odd signal multiply with even, it is t power 7. So t power 7 is nothing but, it is odd signal. Here, I hope all the students are getting. Now next number 7, integration of any odd signal. Correct? Integration of odd signal is even, yes or no? Similarly, integration of any even signal, here integration of t square, it is nothing but t cube by 3, so it will be odd. Similarly, differentiation of any odd signal, differentiation of any odd signal will be even. Differentiation of t cube is nothing but 3t square. And next is differentiation of any even signal is what? Odd. Okay. Next important conclusion, what is the total area of odd signal? Total area of odd signal is 0 or non-zero. Area of any odd signal. Total area of any odd signal. You can see here, this is the odd signal. If you find the area of this odd signal, so positive half cycle area, which is equal to negative half cycle area, so the total area will be 0. Okay. So area of any odd signal, total area integration of odd signal from minus infinity to plus infinity, always 0, guys. Okay. And if it is a even signal, so we can say, see, even signal, area for t greater than 0, which is equal to area for t less than 0. So you can find area for any any side, for the right side or left side, and just you can make it double. Okay. So here it is nothing but 2 times, and you can take half integration, that is 0 to infinite E1 dt. Correct? Are you getting? Okay. I hope all the students are getting what I am saying. Correct? So these are the very much important conclusion. These are the very much important conclusion, guys. Any doubt in any conclusion? Any doubt? Okay. So this is all about odd even signal. More questions are there, but that we will continue in the next class. Okay. So all of you, thank you so much watching me live on Get Wallah English channel, and please provide your valuable feedback after completion of this session, and next part we will continue in subsequent module. Thank you, guys. Thank you so much.